Just a tremendous honor and pleasure to introduce our speaker. He is the Frederick P. Rose Director of the Hayden Planetarium at the Rose Center for Earth and Space, Research Associate in the Department of Astrophysics at the American Museum of Natural History, mentee of the amazing Carl Sagan, host of Cosmos, A Space-Time Odyssey, and author of Space Chronicles, Facing the Ultimate Frontier. Ladies and gentlemen, here to blind us with science, I give you Dr. Neil deGrasse Tyson.
Thanks for that warm introduction, and I just thought we could have fun for an hour. I'm glad you're fed, so that's not a distraction. And they just didn't serve wine or beer for lunch. That's the only drawback. Which makes doing this after dinner a little better, because people are just ready for anything. I tweet, if anybody cares. People say, oh, can you tell me about the latest current events in the universe? That's not what I tweet. I hate to disappoint you, but just stuff that spills out of my head. And that's what you're stuck with, all right? So if you like brain spillage, I welcome you to that following. Otherwise, you like the news sources. But that being said, allow me to alert you that there was a total lunar eclipse this morning. Did anyone catch that? I was asleep, but every newspaper says, rare eclipse, rare eclipse. And you know, eclipses happen more frequently than midterm elections, you know? So, notice this, rare midterm elections coming. So eclipses, they're just lunar eclipses, solar eclipses. There's going to be an eclipse in 2017. A total solar eclipse will go exactly across the entire width of the United States. Be like America's eclipse, right? We haven't had one of those in a while, like from Oregon to South Carolina, so watch for that. But I was just worried because Time magazine took it on themselves to say, astrologer, why you should pay attention to the lunar eclipse. If this were People magazine, I'd say, okay. But it's Time magazine, this is part of the problem that we face in our world. Evidence of how it is that we can get hacked so often. A couple of things, I've been busy lately with this. Thank you all for those who own a TV out there. So, in my Twitter stream, I got the highest compliment I ever got. Ever. I will share it. This is an unbeatable compliment. Before the first episode aired of Cosmos on television, just before it aired, in my Twitter stream, this showed up. Shh. Neil Tyson is about to crack a knowledge egg on your ass. So I said, yes, that's what I do. Yes. I would later learn that Foodmancing tweets a lot of food-inspired content. And so you can have a chicken egg, and this is a knowledge egg. So that's, I gotta get something else off my chest, if you allow me. We have to just settle the score here. Some of you know that I got history, there's a little bit of history here. Some of you know, and people upset about the plight of Pluto here. Still, we got some involvement, and other people seem to be okay with it, sir. Anybody else have issues? Just so you know, it is still not a planet, all right? And if you have problems getting over it, anyone here have problems getting over it? Yeah. Did anyone tell you that our moon is 5 times the mass of Pluto? Has anyone told you that, sir? Yes, you can shake his head. No, I didn't know that. No. Yeah, there are 5 other moons, 6 moons in the solar system bigger than Pluto. No, they didn't tell you that either, right? That's made of mostly ice. No other planets made of ice like that. If you brought Pluto to where Earth is right now, heat from the sun would evaporate that ice, and it would go tail. You don't want planets. The tails. We have other vocabularies for such objects. It just occurred to me there's a camera right here. People will wonder what this hand is doing here. I'll help you with the caption if you need that. So if you still have issues, I just want to say just get over it, all right? That's my lesson to you. The reason why I'm implicated, again, I'm just getting all this off my chest, is 8 years ago, well actually 14 years ago, in New York, we redesigned our facility and we regrouped Pluto with other icy brethren in the outer solar system that had just been discovered. And then we got raked over the coals. It's a page 1 story in the New York Times. Pluto not a planet, only in New York. And I got hate mail from 3rd graders. This is just an example, okay? Dear scientist, what do you call Pluto if it's not a planet anymore? If you make it a planet again, all the science books will be right. Well, why is an elementary school child concerned about the profit margins of the publishing industry? Do people live on Pluto? If there are people who live there, then they won't exist. Why can't Pluto be a planet? If it's small, doesn't mean it doesn't have to be a planet anymore. Some people like Pluto. If it doesn't exist, then they won't have a favorite planet. Please write back, but not in cursive, because I can't read it. I had to deal with this for 6 years. Okay, just got that off my chest. Cleansing breath. So, now we can begin. I just want to spend a couple minutes just telling you just how science works. You guys are science literate, so you're not the problem out there. The problem are people like in charge who are not science literate who think they are, making decisions that are underinformed, misinformed, and the like. And so I just thought I'd spend a couple of minutes. You surely already know this, but even if you do, this might be packaged in a fresh way for you to then share with others. Generally, when we think of our 5 senses, our traditional biological 5 senses, we can recite them. We can see, we can hear, we can smell and touch, and taste. What was that? 5? Yeah, that's 5. And then occasionally you get people who say, I have a 6th sense. We know people like that. One of those people like in this room, raise your hand if you can do that. It's okay, we're among friends. Sir, you think you have the 6th sense? Okay. More of you broke the ice, sir. Now others are confessing. Okay, so rather than be impressed with your 6th sense, because I know, that works at the cocktail party, but I want to say that I'm not impressed with your 6th sense, because, You know who would be impressed with your 6th sense is Edmund Hubble. Edmund Hubble is attributed with this quote, a beautiful quote. So it's equipped with his 5 senses. Man explores the universe around him and calls the adventure science. But Hubble had a 100-inch telescope at his disposal. That doesn't count as being one of his 5 senses. All right? His eyeball is not 100 inches wide. All right? He doesn't have the detector capabilities that was at the business end of that telescope. So this is poetically reflective. The fact is, even if you have a 6th sense, science has many senses. We can detect magnetism, and we have multispectral vision. We can see, X-rays, radio waves, gamma rays, microwaves. None of your biological senses can detect these. You can sort of detect infrared, not sort of low energy infrared, slightly higher energy infrared, but otherwise, if I turn out all the lights, you're all glowing in infrared, and we have no idea that you're doing that. But I have detectors that can. We can measure polarization, radioactivity, ionizing radiation. Now, we can sort of detect ionizing radiation. It's when your limb falls off. That tells you that it happened earlier. So I don't know if that counts as a detector, you know, but your body responds to it, but not immediately. And so we need ways to help this out. So I'm not impressed with your sixth sense because we have dozens of senses. These are the science senses. And so, sorry, I went back to that. You get to see them the second time. There we go. You got that? Okay. And then the scientific method, you might have read about this in school. They talk about induction, deduction. Forget it all. Forget it all. That's after the fact. That's an analysis of what we figured out that we were doing once we were doing it. You know what the scientific method is? It is simple. It is, thou shalt not fool thyself. That is the scientific method. Do whatever it takes to not fool yourself into thinking something is true that is not, or have you think something is not true that is. That's the only thing the scientific method is. And it's a tacit recognition. It's a tacit recognition that scientists are human. We have biases, we have prejudices, we have all the things every other human has. The difference is our system of measurements and data taking help to ensure that we don't fool ourselves. It doesn't mean that's impossible, but it greatly reduces that likelihood. We want to remove the five senses as far from the experiment as we can, because there's nothing as error-prone as the five human senses. You know how error-prone it is? We've all had books that have optical illusions. Who doesn't love a good optical illusion? We all love optical illusion. Why don't they title those books Brain Failures? That's what they are. Brain failures. A simple line drawn. Oh, is it in the page? Out of the page? Is one line longer than the other? I don't know. Oh my God. That is a failure of the brain-eye system. And you want to use that to decode the nature of the universe? That's why we invented science, and methods and tools of science, and the other dozen senses that these methods and tools provide us. Also, let's understand what theory is. Okay? Theory, the word is used, and people don't, I won't tell you what theory is, right? An understanding of nature that explains a broad area of what is known and successfully predicts what is yet to be discovered. That's a theory. Okay? That's what a theory is. And out of that, we have things like the theory of gravitation, and evolution, and relativity, and quantum theory, and orbital theory, which is really a derivation from gravitation. But these are theories. Etc. If you have an idea and it's not yet tested, don't call it a theory. Call it a hypothesis. A hypothesis. You have an idea of this, how something like nature might work, but maybe you haven't tested it yet. Call it now. So I've been trying to change, I've been working hard on my colleagues who are working on the theory of everything. These are the string theorists who are out there. We know who they are. And I'm trying to think that it should really be renamed, it's the hypothesis of everything. It's less romantic, but far more accurate. And that way it doesn't cheapen the usage of the word theory in these other branches of our understanding of the universe. What are you working on? I work on the hypothesis of everything. Think you'll ever get used to that? Yeah, I think I agree. They liken the theory of everything. Puts them at the roots of it all. But it is nonetheless a hypothesis. Now watch what happens. The theory of gravity and motion together with that can be represented in these two equations. It's just letters. It'd be nice if I had like equation mode in the slide. But so these are two equations, like gravity equation and motion equation. Isaac Newton came up with this. Isaac Newton. And look what happens. Once we understand how gravity works and how motion works, then people wage war with projectiles. That's kind of interesting. They had projectiles before this, but you just kind of point and shoot. Nobody could calculate where the cannonball was going to land until these equations arose. So it's kind of interesting. We have a new understanding of nature, and people want to invoke war with it. How about relativity theory? Well, we know what came out of that. V equals mc squared, perhaps the most famous equation ever. The equivalence of mass and energy. You can convert one to the other and back. And out of that, many decades later, becomes nuclear weapons based on this principle. And so now we have war derived from another huge theoretical branch of physics. And orbital theory is really derived from gravity, but to think about orbits was a whole other exercise in math and physics. And out of that, you get rockets. You get the rocket equation, wasn't around before about 100 years ago. This is the equation that says you need this much fuel to launch the fuel you haven't burned yet to a position where you then burn it. That's why the Saturn V rocket, 32 stories tall, the astronauts in the little bitty little capsule at the top, and all the rest is rocket fuel. The rocket equation. Once we had an understanding of that, combine that with orbits, we had rockets. And now there's all this talk about what is the future of space. Will there be space wars? Just a curious trajectory of human investment in intellectual capital. Quantum theory. Love me some quantum theory. Traceable to the 1920s. That's a decade that is not as celebrated as it ought to have been, as it still needs to be. In that 10-year period, we discovered quantum physics. We discovered, oh, that's me now. Go back. No, all of a sudden, like, something was moving over here. It's like, the camera's following me. Let's check this. Okay. Don't you hate that when you see me? What was I talking about? Quantum, thank you. Quantum, 1920s. Quantum physics gets invented. Hubble, Edmund Hubble, not the telescope, that would come later. Edmund Hubble, the man who talks about his five senses, discovered that our galaxy is one of the countless galaxies in the universe and that the universe is expanding. All that happened in the 1920s. Now, why do I mention this? Because there is no IT revolution without quantum physics. The IT revolution depends on how you date it, maybe 50-year delay from the 1920s into the 1970s, before information technology became a major part of our economy. That began basically in the late 70s, definitely in the 80s, and certainly in a big way in the 1990s. And so then you have cyber war. Each one of these, I'm intrigued by this. We have a new understanding of the universe, and then people find a way to create war with it. Quantum theory, that's the best example of why investments in things that you might think nothing has anything to do with anything. If you were around in 1920 and you're a physicist talking about probing the atom, I can't see the atom. Why are you doing that? Well, all I care about is that atoms become macroscopic objects, like wine glasses, okay? I'm good with that. I don't need to know that it's made of atoms or molecules or what holds them together. It works. How many people would have, if given the option, said, don't spend money on that? We have hungry people in the street. Where are your priorities? There's quantum physics getting developed. There is no computing revolution without quantum physics, and that was a 50-year, 60-year delay. Can't expect a corporation to invest R&D on that time scale. Governments have to do that. If they don't, they recede. And who works on this stuff? Like really smart people. You want smart people doing smart things. A good society will find them. If you disenfranchise half the population, you're missing some smart people. You're missing some people who might have ambition that could serve the future needs of your state. So Isaac Newton, in 1666, not only came up with gravity, and I speak if you type Tyson and Newton on the internet, there's 1,000 links. So I will not spend much time on Newton with you now, because it's on the internet. There's even one where it's best viewed if you're high. If you type, so first do Tyson and Newton and go to that link. Then go Tyson, Newton, slow motion. Some videographer with too much time on his hands took one of my reflections about Isaac Newton and slowed it down. And I looked at it, it's simultaneously disturbing and hilarious. Anyhow, me and Isaac Newton go way back. But the point is, he's thinking about the universe, and he comes to a problem he can't solve. And so now you have the genius of someone decoding the universe, and then he says, there's not enough math known to solve this problem. I guess I'll invent some. And so he invents integral and differential calculus to solve a problem. Just on the side. Like before breakfast. I don't know if it was before breakfast, but the guy, I mean, people slogged through this in school, just learning it, and he invents it just to help himself solve some problems that he thought were kind of cool. Edmund Halley. Yes, you recognize the name from Halley's Comet fame. We actually mentioned him a bit in the Cosmos series. And that year, 1893, I cited for you because not only did he use Newton's laws of motion and gravity to predict when the comet that now bears his name would come back again, in that year he found data on a German city where they kept track of dead people. He made the first actuarial tables. An astronomer. When you're an astronomer and you spend your whole life thinking about it there, and occasionally you're looking down on Earth. Oh, here's Earth. Are the problems we need to solve? Let me put some energy there. So I'm intrigued by people who take their intellect, otherwise applied to one branch of science, and then sort of slip it into another place. The concept of actuarial tables are traceable to the work of Edmund Halley in that period. Old Romer, this guy's great. He was the first to measure the speed of light. The speed of light, a brilliant concept. He noticed that the eclipses of Jupiter's moons happen 500 seconds sooner than they're supposed to when Earth is on Jupiter's side of the sun. And then when Earth is way back on the other side of the sun, they happen 500 seconds later. So the total time difference is 1,000 seconds. And he said, maybe this delay is because it takes light time to span the diameter of Earth's orbit. Well, what's the diameter of Earth's orbit? It's twice 93 million miles. 186 million miles. 186 million divided by 1,000 seconds gets you the speed of light for free. What's 186 million divided by 1,000? 186,000 miles per second. Look it up. That's the speed of light. Romer came up with this. Meanwhile, one day he broke his leg, was laying at home, and he said, I think I'll invent a thermometric temperature scale. So he invents a temperature scale that Fahrenheit checks out, and it is the foundation of the Fahrenheit scale, which would This is 100 years before the Celsius scale and the French Revolution, when that was sort of introduced to the world. But on the side, he invents a temperature scale. Gauss. Gotta love Gauss. Brilliant mathematician. In Germany, okay, he was a mathematician, so this kind of doesn't count in my examples. But beginning in 1795 and up through 10 years later, he's trying to figure out new mathematical ways to understand how things work, how orbits work in the sky. And out of that he pioneered, in order to understand the orbits of newly discovered asteroids. The first asteroid ever discovered was 1801. We called it Ceres. We thought it was a planet. Nobody ever found an object between Mars and Jupiter before. It was called a planet. You've heard that story before, haven't you? Then we found another one of these things. Oh, we found another planet. Oh, and another planet. I have books from the early 1800s that list 12 planets in the solar system. Once we found out that all these objects were just very different from all the other planets, we realized we discovered a new swath of real estate. We call it the asteroid. Asteroid means star-like. They're so tiny, they just leave a dot of light in your photograph, the way a star does. Asteroid. The first one discovered, it got lost in the glare behind the sun. Where is it going to show up on the other side? Nobody knew. Gauss figured this out and developed a whole set of mathematical tools to figure out the future location of something based on some original data. And out of that came the methods of least squares, which is the statistics 101. So least squares, which you learn in a statistics class, came out of just a curiosity of Gauss. Florence Nightingale, we'll know her as a famous nurse, saved lives, all this. Have you seen her publications? What she published? She analyzed the sickness and the death at the Crimean War and other wars where she was staged. And she presented the data. She pioneered the display of quantitative statistics. No one before her really thought that you could talk numbers other than just putting tables of numbers. She found ways to display numbers so that at a glance you understood what it was about. And in there was some of the earliest uses of a pie chart and a polar plotted chart that can show you the deaths of soldiers by month in a glance and what the causes are. Pioneered an entire new branch of communicating data. Florence Nightingale. Albert Einstein, 1917. We all know him from relativity, E equals mc squared. What you might not have known is in 1917, he published a paper called The Stimulated Emission of Radiation. If that's all he did in life, he'd be one of the most famous scientists ever. That paper is the foundation of the laser. But I bet he wasn't thinking, hey, barcodes, yes, this is why I'm doing this. Yes, LASIK surgery, yes, we can, oh, tattoo removal, yes, this is why. 9 years later, he'd write a paper on the meandering of rivers. Alan Turing, there's only one in there, Turing. Alan Turing, no stranger to this audience, is a mathematician, but interesting that we would figure out that mathematicians would be good for code breaking. It's not an obvious, there's some numbers and you gotta be smart, but maybe you just need someone with an eidetic memory or some other talent. Mathematician, Alan Turing. He'd be the father of computing theory, recognized world over. So I gave that list, and I just plucked them from the annals of history, just as an example of the problem-solving ability you have when you have the freedom to just explore the unknown. When you have that freedom, then your brain can go places that someone else doesn't require that it goes. And that might be a new place that benefits everybody. It happens more often than we admit. And I wish it would happen more often than we would ever know. So, who leads the world? You know who leads the world? The people who invest in science and technology. That's who leads the world in practically every way. And I'm told you guys had some periodic table of the elements floating among you. Except it was reconceived. Is that good? Oh, she's holding up the periodic table. So here's the periodic table. I practiced this. I spent time in Texas, right? There you go. Any Texans here? Did I get that right? Yeah. That's pretty good, right? There you go. Vote of confidence for the two Texans right here. Periodic table of the elements. I love me some periodic table. And this is color-coded by valence, electron, I guess, or maybe some other, by family. Okay. And so there's some cool things in here, like elements that we know and love. Since I've spent so much time over there, I want to come down over here. Doesn't mean I don't love you over on the left side of the room. Notice element 92. It's the element U, uranium. That's actually named directly after the planet Uranus, which had just been discovered a couple of years earlier. And then that element was discovered. They said, let's name it after the planet Uranus, and they called it uranium. And then they saved the element after that in case new planets would be discovered in the solar system. Indeed, one was, the planet Neptune. So element number 93, Neptunium. And then 1930 comes along, the object known as Pluto gets discovered. 1940, we isolate an element in the lab, and thus is born the element plutonium. So Pluto ended up on the periodic table on false pretense. So I always have the urge to take a Sharpie and put an X through it here. I just want you to, and again, we're looking at the bottom row here, over on the other side of the hall. So we have uranium, neptunium, plutonium, we have californium, berkelium. Wait a minute, berkelium, californium? What's going on there? I'll tell you what's going on. If I now swap out the colors of these element families with the flag of the country who discovered the element, here's what you find. Ooh. Look at that bottom row. That's America. America's planet. So we discovered all those elements, and so we got to name them. Hence, we have californium and berkelium and Lawrencium, 103. And americium, that element, by the way, if you discover a new element, it has properties no other element has, typically. Americium is the active ingredient in every smoke detector that's made today. Americium is an isotope of that. And when you talk about the people who are not dead because they're saved in house fires, when I grew up, the big thing was, well, do you have fireproof underwear or fireproof pajamas? So you want to believe that that's what's saving lives, but if the flames are close enough to you to ignite your pajamas, you don't want to be in that situation. But smoke detectors, you know it long before. There are flames on your pajamas. So new elements you have the power to lead the world in so many ways. And how about the column on the far right? What do we call that group of elements? The noble gases. Yes. The noble gases, these have complete outer electron shells. They don't interact with anybody else. And then we learn that the Brits discovered practically that entire column. That means the Brits got to name this group of elements. And the Brits said, oh, these elements don't interact with anyone else. Who in our society doesn't interact with anyone else? The nobles. And I'm reminded why we fought a war to get the hell out of England. Their class system is on the periodic table of elements. I get pissed off. I don't know if they knew fully at the time that the noble gases don't even interact with each other. So a better term would have been the hermit gases or the loner gases or something to actually indicate the fact that they don't combine with anybody. So you get to name things and you get to see who is leading the world. Look at that list. Sweden is an interesting exception here. Oh, you have a Swedish person in the front row. Okay, so the rest of those countries, the United Kingdom, Germany, France, United States, Russia, this is a roll call of the most powerful countries in the last 200 years. And Spain used to be powerful, but they did not really come into the Industrial Revolution the way other countries did. And I've spoken with Spaniards about this. A history of discovery and exploration that all just kind of stopped. And my high school has 8 Nobel laureates among its graduates, 7 of them in physics. That is as many Nobel laureates as the country of Spain. So I had to find out, I know you had a civil war midway, but before then and after then, what's going on? And I found out from this Spaniard, who's a colleague of mine, that in the culture, people are not thinking, oh, here's a problem that's hard, let me go solve it. She was candid with me and said, look, if there's a problem that's hard, we just say it's hard, maybe it'll never be solved, and they go back to their coffee. So there's a cultural difference, and what is your attitude towards solving a problem? A cultural difference. So we go back to that list, we see countries that were kicking butt and taking names in every possible way for the past 200 years. Now, why is Sweden on the list? I'll tell you. There's a cave in Sweden.
There's all that weird stuff that they found in one...
Yeah, exactly. There's one cave in Sweden where you walk in and you came out with a new element every time, right? Oh, here's another one. There we go. It's near the town of Ytterby. Did I pronounce that correctly?
Yeah, Ytterby.
Oh, it's Ytterby.
Ytterby.
Yeah, okay. That's exactly what I said, isn't it? YTTERBY, something like this. So the first element, they call that ytterbium. Then they found another element. What do you do now? They call that one terbium. They took away the right? And then the third element that came out, they called that one erbium. They just cut the syllables out, named them after their town. But now there are no syllables left. What do you do? So, particularly fertile cave, Sweden didn't have to dominate the world in order to end up on this list. They had a good cave full of elements. And one of them is called scandium, to honor all of Scandinavia. These are where these elements came from. There was also national pride in science. I collect currency that has scientists on them, pre-euro currency among them, back when this was a pastime. And I just love it. It's beautiful, you know. And Darwin and Tesla and Saint-Exupéry in the middle left. He's not a scientist, but an aviator. Wrote beautiful poetic prose about flying. Copernicus and Volta and Marconi, the pioneer radio signals in the bottom right. In Italy shows up twice in just this one slide. What's kind of cool for me here is that we have Tesla in the upper right and Volta in the lower left. Each of them have a car brand named after them. Tesla and Volt, electric cars. We keep going. Oh, we flip over the currency on the right-hand column of the previous slide. You see the electricity that Tesla worked with. You see sort of a heliocentric solar system, and you see the radio towers. Romania, that's the currency on the right there. That's kind of cool. They had a total solar eclipse go across the country. They were so enchanted by it, they put it on their currency. You see the track in the lower, there's two sides of the same note. That's the eclipse track. You flip it over, and then the artist, I think, had a little too much freedom there, representing the solar system. And I don't know what that menacing pink blob is. It doesn't look good for the solar system, I think. Plus, you don't want menacing things to be pink. That's just my personal preference there. Even the Middle East is in the act. We've got Alhazen, who we profiled in Cosmos from 1,000 years ago, a brilliant mathematician and scientist. This is an Iraqi 10,000 note, and he deduced how sight works. Before him, people thought that sight was you beam something out of your eye. So if I looked at you, I was beaming at you. This is what led to people think that, oh, I can feel you looking at me. The idea that your eyes beam things out created an entire pseudoscience around people looking at you. He showed that it's a completely passive phenomenon. He's honored on the currency. Albert Einstein is not Israeli, but when you're that famous, everybody wants a piece of you. So he's on Israeli note there. Any Canadians in the audience? Yeah, okay. Canadians, your $5 bill formerly looked like this, and you had hockey players on the back. So, I'm curious, did you really feel the need to remind your own country that you liked hockey? Was this really necessary? I thought this is pretty clear. At the border, you're handed a hockey stick. So if you had to swap out the currency, this is the one you would do it with, and it's exactly what they did recently. Their $5 bill now looks like this, and on the back is the International Space Station Canada arm, a brilliant feat of engineering that can maneuver telescopes, grab them, deploy them, put them in the payload. And we think that's Chris Hadfield, one of the most famous astronauts, certainly the most famous Canadian astronaut there. And, okay, there's that menacing thing again, except this time it's a maple leaf. Like if I were that astronaut and I looked over my shoulder and I saw a fuzzy maple leaf coming towards me, the size of the Earth, and it's fuzzy too, right? It reminds me of the comedian Mitch Hedberg commented that one of the scariest things to him, he was afraid not of Bigfoot, he was afraid of the possibility that maybe Bigfoot is actually out of focus. That's what scared him the most. If an out of focus creature comes after you, what would that mean? You know? This goes on, I don't want to waste more time on this, but Euler from Switzerland and Galileo, Italy, now a third time up here. My man, Isaac Newton in the middle left. Unfortunately, they don't print the £1 note in paper anymore, it's just a coin. And Pasteur in the lower left. Faraday, almost an entire episode in Cosmos on that. And Gauss in the middle right. Karl Friedrich Gauss, we mentioned him earlier. Now, if I ask you, what country is the first to come to mind when you think of quality engineering in the world? What country? Germany, of course. It's a selling point. German engineering. That's why you would choose to buy a product. Okay? So, perhaps other countries have excellent engineering. But apparently it's not in the marketing legacy. There's no product on the shelf that says Polish engineering. Maybe it's good, but it's not. So the question is, what is going on in Germany? It's not just a charade. They actually make good stuff, quality stuff, high precision stuff. So what's going on? I labored over this because I care about culture. I care about how an entire body of people think in ways they don't even know they're thinking because it's just in the culture. It's in the culture. My first trip to the Far East, I went into one of their marketplaces. It was an entire aisle of rice. All kinds of rice I didn't even know existed. And I had a repeat experience when I visited one of the larger grocery stores in Italy. An entire aisle of pasta. Pasta fusilli number 8. I've never seen that before. So I went to the Italians and I said, do you notice that you have an entire aisle of pasta? And they said, no, that's just the pasta aisle. So I said, when you come to America, because I had to avert this, when you come to America, is there something you notice in our store? that clearly I don't notice because it's just a grocery store to me. They said, oh yes, there is. I said, no. They said, you have an entire aisle, both sides, of soda. And I said, yeah, that's just a soda aisle. So what? Nobody else has this. Okay? There's a section of one aisle where they have the soft drinks. I said, anything else? Yes. The ready-to-eat breakfast cereal aisle. Both sides, floor-to-ceiling breakfast cereals. Well, we pioneered the marketing of soft drinks, primarily through Coca-Cola. We invented ready-to-eat breakfast cereal. It is part of our culture and we don't even know it. That's what I mean. Is there some thought you have? Is there some way you behave and you don't even know you're behaving that way because it operates deeply within the culture? So I looked to Germany and I said, is there some, what? And I looked at the 10 Deutschmarks, the Gauss sign. I'm a brilliant mathematician. It pioneered least squares. And I said, wait a minute, holy cow, there's a mathematical distribution function on the currency. What? Yeah. This is the famous Gaussian bell curve, the normal distribution, the bell curve. That's what this is. F of x, sigma, 2 pi, square root, mu. Right? It's got it all. Can you imagine petitioning the U.S. Congress saying, I'd like to put some equations on our currency? So if you're a kid in Germany, you don't know what that formula is. You don't even know, but you know it's important. It's on your currency. And who's this guy? Is he some leader? Is he some politician that comes and goes, depending on the political winds? No! One of the most brilliant mathematicians there ever was, and he's on their currency. I can't help but think that forces such as this, operating down in the landscape, promote a culture that embraces science and technology. Do we have a scientist on our currency? Yeah, Ben Franklin. So, okay, so 8 of you have seen a $100 bill. Okay, good. All right. The rest of you just have to work a little harder, right? so Ben Franklin's a scientist. So we flip it over, we say, okay, where's the iconography of his science? He was a brilliant in electricity. Is there a lightning bolt? No. Is there a kite with a key? And there's plenty of real estate. You could have put all kinds of stuff on the back of this. There's just Independence Hall. He's on the money not as a scientist, but as a founding father. Which I think is great to honor him this way, but it's also a lost opportunity. So where are we headed? Here's a map of the world with countries shown with proper area relative to how they would be drawn on a globe, which means it's just a regular map. Okay, just so we're on the same page. What we now do is distort the area of each country according to certain interesting parameters. So that at a glance, Florence Nightingale would be proud of this. At a glance, you get to see which countries lead or trail in a particular thing. So let's look at internet usage. All right, internet usage back in 2001. Okay, ready? So if your country's area expands, it means you're using it more than everybody else. If it shrinks, it means you're using it less than everybody else. So here you go, ready? So that's 2001, or 2000. So one of the great tragedies is that Africa practically disappears on this map. Western Europe is riding high, so is, what's that purple thing on the far right? Japan. All right. So now let's look at internet use in the world. I have the latest data available on this from up to 2007. Right? Compare this image with 7 years later. 2007, 2000. Some trends here. We are no longer the significant internet player in the world. And who just got really fat between these two zones? China got fat. You know who else got fat? This blob, this green blob, sorry, the greens are close to one another. They should be different colors and they're not. But there's a blob between Japan and China. That blob is not even visible on this chart. What is, oh, there it is. See that little itty bitty blob to the west of Japan? That's South Korea. People's the Republic of Korea. Korea, there's Korea. Oops. Sorry. Yeah, that cool? We'll get to that. So, look at the size of South Korea in this. Huge. Japan, huge. Western Europe, huge. United States. We're fading relative to the world. Somebody's got to wake up to this. We're fading. I'm old enough to remember these dreams. Some of you guys see some gray hair in here, you'll remember this. It wasn't just the drugs. We actually thought up futures like this. Right? Tomorrowland. The city of tomorrow, the home of tomorrow, transportation of tomorrow. Flying cars. I claim that this was fueled because we as a country had in our culture the fact that we were exploring, we were pushing a frontier, we were going to the moon. We went to explore the moon, and you know what else happened when we got there? We discovered Earth for the first time. Everything I've been saying up till now is some kind of a cosmic perspective, a view from above, where you're not mired in the detail, you just see the general trends of how things are, of how people think, of how people treat one another. We went to the moon to explore the moon, and we discovered Earth for the first time. You know, I know we discovered Earth for the first time because there it is, with not color-coded countries and cities and boundaries. Is how nature intended you to see it, with oceans and land, clouds. Do you realize before this image from Apollo 8 in 1968, they didn't land on the moon, they orbited 15 times, and as the moon rose up above the Earth's, as the Earth rose above the lunar surface, they put this photo, Earthrise, on the lunar landscape. And before this photo, no one had really thought to draw Earth with clouds on it. Here's a cover story of Life magazine. New portrait of our planet Earth with no air. What are people breathing? No one connected Earth with the atmosphere culturally before that photo. No one thought to think that maybe the atmosphere matters. And you think that was just because that's 1960? We go forward. How about Star Trek? How did they do? Nope. No air over North America either. The space program, no matter what else you think of Tang and, which actually predated the space program, by the way, just got a really big boost in sales because the astronauts drank it. Whatever you want to say, the real value of going to the moon was the cosmic perspective it gave us. A perspective that changed how we think about our place relative to each other and in the universe. Carl Sagan convinced NASA to take the Voyager camera. Voyager was the space probe that went out to the... It has enough energy to leave the solar system entirely, and we featured it in several episodes of Cosmos. So, in 1990, Voyager passes Uranus, the last planet in the solar system. Carl Sagan convinces... I said get over it, didn't I? Carl Sagan convinces NASA to have Voyager turn its camera back towards the inner solar system and take a picture of Earth. This was Earth's very first selfie. That image produced what has since been known as the pale blue dot of Earth. Carl Sagan wrote a whole book with that title, with reflections on its meaning and significance. That image was reprised just last year with the Cassini mission to Saturn. This is an actual photograph of Cassini in orbit around Saturn, where Saturn has eclipsed the sun behind it. That's why you see this rim of light around the ball. This is sunlight peering through the thin layers of the outer atmosphere. The rings are lit from below. It is stunning. My colleague, Carol Porco, who's in charge of the imaging on this mission, said, if I look back towards the inner solar system, one of these photos should capture Earth. Because Earth is back down in here in the inner solar system. And so she did this. Jessica, can I have the lights out? Ooh, that's beautiful. She took a photo of Earth from Cassini. And there it is. So I want to end with, you don't need that arrow. There we go. I'm going to end with a recitation from the book of Karl, the pale blue dot. If you look at Earth from space, you see a dot. That's here. That's home. That's us. On it, everyone you've ever heard of, every human being who ever lived out their lives, the aggregate of all our joys and sufferings, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilizations, every king and peasant, every young couple in love, every hopeful child, every mother and father, every inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust. Think of the rivers of blood spilled by all those generals and emperors, so that in glory and in triumph they could become the momentary masters of a fraction of a dot. Think of the endless cruelties visited by the inhabitants of one corner of the dot on scarcely distinguishable inhabitants of some other corner of the dot. How frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our planet is a lonely speck in a great enveloping cosmic dark. In our obscurity, in all of this vastness, there is no hint that help will come from elsewhere to save us from ourselves. It's up to us. To my mind, there's perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. It underscores our responsibility to deal more kindly and compassionately with one another, and to preserve and cherish that pale blue dot, the only home we've ever known. Thank you all for your attention.
Please let him take 2 questions.
Tight clock here.
All right, 2, real quick.
Questions about
Let's
these
do it.
videos. I'm sorry, I didn't hear that? Oh, did I write back to the schoolgirl? To Madeline Trost is her name. So I actually included that letter with her permission in my book, The Pluto Files. And I don't give book talks, so you would have never heard me even talk about Pluto, other than that little snippet. We got her permission. She really didn't care anymore about Pluto. She was, well, in high school with other hormonal directives. So this is what happens. The most important thing in middle school is not the most important thing. So she's brought back into the fold. Thanks for that follow-up question. Another question? Yes, right here.
So if you've got 9 Nobel laureates from your high school, what are they doing right?
Okay, so she said we've had 9 Nobel laureates from our high school. It's actually 8. 8. You upped it since. Did I miss an announcement? It'll be announced in these couple of weeks. What do we do right? I think it's a culture. In my high school, the Bronx High School of Science, it's not that they taught us to be Nobel laureates. It's that the culture of that environment is one of curiosity. Think of how much time we all waste, dare I say, doing nothing between other things that you're supposed to be doing. What are you doing when you're moving between classes, during study hall, during lunch break, on the walk to the bus stop? We were talking about theories of the universe. There's a friend of mine, well, in my math class, we just learned about the laws of the French mathematicians, Laplace, Lagrange, Legendre, and there's a friend of mine named Frank Laurice, and he couldn't stop thinking about a series of equations called the Laurice equations after we've been through this exercise learning about the French mathematicians. It's this kind of random banter that sets a cultural expectation that you're going to remain curious your whole life. And I claim that in that era, in the 1960s, why would we say, if you put a man on the moon, why can't we then solve X, Y, Z? We had a place to stand and say, it's time to solve these problems. And we knew that the solution to those problems were technological and scientific. The STEM fields, before the word STEM existed, were known to be valuable to creating that future, though partly drug-induced in its appearance. Nobody's talking about Tomorrowland anymore. We're waiting for our next app. Now, I love me some apps, don't get me wrong here, but society has bigger problems than what can be solved with your next app in transportation and energy and health. And these are huge sectors of society. And they're solved by innovations in these fields. Without it, we might as well just recede back to the cave, because that's where we're headed. We're headed back to the cave even if we stand still, because it'll look like we're going backwards while everybody else is passing us by. I grew up in a country where America discovered all those elements. That's not happening today. The center of particle physics is in Switzerland. Interesting thing about science, it doesn't matter who does it. It transcends culture and language and what religion your parents were. Nobody owns the science. It moves around the world. It was in Baghdad 1,000 years ago. It was in Europe 200 years ago. It was in the United States in the 20th century. I see the culture, our nation, we're a sleepy nation right now. I want us to become an innovation nation. That's the one I remembered. In spite of the turbulence of the 1960s, the civil rights movement, campus unrest, political assassinations, a hot war, a cold war, we haven't been to the moon. There was a perspective. There was an attitude. There was an outlook. That's what shaped an American vision. Go ask anyone around the world about America in the 20th century. If they get past our politics and all the rest of that, if they didn't like it, at the end of the day, they'll say, you guys invented the 20th century. We invented computers. So, look, it's a free country. We can do what we want. We tell ourselves it's a free country. We do what we want. We vote who we want. I see pathways to wealth and health and security that don't come about just by wishing for it. It comes about by a cultural shift. Does it mean put some equations on our currency? Plenty of unused real estate on those surface, on the backsides of those the greenbacks. Yes, maybe, I don't know. I don't have the silver bullet here. But it's the observation that is clear as day to me. That if we don't leave the world, someone else will. And part of your job as internet security professionals is to protect the intellectual property, to make sure it's not, as a minimum, not stolen, and then next, not corrupted, which would then stall everything down to a halt. So that's no different from like 200 years ago, you have the guards out front. No, you're not coming in because we got important stuff going on here. You're going to have to come through me. That's the sort of the internet version of that. We need that. You're the secret front gate to all of this. The rest of us don't think about what you do. That's kind of a good thing, right? We just want to just do our thing. You're like secret sentinels. You're not secret, but you're hidden from most of what anybody thinks goes on in the world. But you need that just as much as you need everybody else to invent the stuff, because you have to protect that once it gets invented. Anyhow, we're way out. We're like, this clock has red all over it. And then it's like, when you shut the hell up, it's time to go. There's screens here where they're talking. Thank you again for your hospitality.